Welcome back to another HVAC-Engineering-Techie training video. Today's video is on sanitary waste and drainage plumbing systems. So this is the first plumbing module for basic plumbing understanding what systems are. Remember, this is a channel that talks all things HVAC and building systems, including HVAC and plumbing and electrical. So don't forget to become a subscriber if you're not already. If you are a subscriber, boy, I really appreciate it. If you're not, I really appreciate you doing it. It costs you nothing, absolutely free. No one will bug you. The reason I need you to do that, I would like you to do that, is Google uses that to evaluate my videos. All you have to do is push that subscribe button down below. Give me a thumbs up if you like the videos. Kind of keeps me on the air, so I appreciate that. So let's get started talking about sanitary waste and drainage for plumbing systems. Thanks. All right, before we start, let's take a look at what our plumbing system training sessions actually have. What do they entail? So the first one is D12 for plumbing system design. It explains how you actually design plumbing systems. S-35 is sanitary waste and drainage plumbing systems, which is this video, and it covers the different waste and vent systems for different plumbing systems. S-36 is a plumbing of domestic water, which includes cold water, hot water, and all the different systems that involve the cold water side. S-37 is plumbing special systems, which includes fuel systems, compressed air systems, steam systems, medical gas systems, process and plumbing control systems. And the last one is CX-14, which is a commissioning of plumbing systems. And all of this information is intended to get you up to speed on plumbing so you can be an effective commissioner. It also helps a beginning designer kind of get an overall of the entire systems. All right, we're going to start on sanitary drain and vent systems. So sanitary systems, waste piping from toilets, urinals, lavatories, and showers. And that's, of course, this pipe down here. And remember that all plumbing is code-driven because it's a life safety issue. Try to prevent disease and waste contamination. So basically, they have all these code requirements for plumbing sanitary drains. And then they have vent systems, which allows the systems to drain properly. And all of these, the way these happen and the distances and how many fittings should be in is all code driven. And that's fully explained in the design section. So this is the drainage, and this is the vent pipes. The vents are actually way oversized. I mean, to vent a pipe of air, you don't need this large of piping, but it's been field tested. They've got facilities that are solely designed just to test systems. And this has been tested to be totally reliable, and that's why they're the size they are. Sanitary waste piping from bathtubs, wash sinks, kitchen sinks, and floor drains. Sanitary waste pipe vent system from building pipe to atmosphere. Waste piping system from building to the utility sewer, our septic system. So every residence and every commercial building has a special waste system that wastes and goes down into normally municipal sewer mains. And if they're in an area that doesn't have sewers, then it'll go to a septic system, which we'll talk about later. And there are certain code requirements where clean outs are installed so you can adequately clean these or jet these lines so they never clog. So grease traps. There's grease trap systems that are put in buildings that might have accumulated grease if they have kitchens or some other process that might put the wax or grease in it. Then you'd have these grease traps which allow the grease or oil to be accumulated in one area, and those are periodically pumped out so to keep the grease and oil from entering the sewer system. The reason we don't want it in the sewer system is it tends to clog up the sewer lines. Sanitary waste devices, so there's floor drains and trap primers. What these are is we put floor drains in the floor to collect overspills or to collect wash down when we wash a floor or something. Well, these have traps, and these traps are, of course, intended to prevent vapors from coming back into the space because these lines have gas in them from the sewage itself, so we wouldn't want that coming into the space. It's not very pleasant. So what they want to do is they want to keep this trap full of water so it becomes a blockage to the atmospheric pressure coming back into the vent system. So to do that, we've used trap primers for many, many years, and they also may use what's called a trap seal. And we'll talk about that. These are trap primers, and this is an electric trap primer. This is a drip trap primer, and this is a trap seal. And what this one does, really, this one is in a wall somewhere, and it has a water pipe going to it, and it has a water pipe going down to the side of the trap. And you would just adjust this manually so it has so many drips an hour that will keep that trap full of water, and it won't evaporate out. This is an electric one, and this one you put in the wall, and it has, this might go to 4 or 5 different traps, and it just basically turns it on every few minutes, maybe every day, and just puts in enough water to fill the trap. And that's to keep it so you don't forget. Because what happens if you have just a regular trap, the water will evaporate out of the trap, and then you won't forget because it will put gas into the systems, into the space. And this is a trap seal, and what it does, it has a mechanism that basically when it's dry, it's sealed, and when water gets on top, it opens up and lets the water flow. And this is a trap seal, so it doesn't matter if the trap is dry or not, the gas won't come to the space. And we have grease interceptors, and like I explained a few minutes ago, this is a grease trap where the water flows in, and the grease and oil is accumulated here. And this actually, then when it gets full, this water is transferred over to here. And the wall prevents it from going to this space, and this tube, sometimes there are different kinds of pipes that allow the water from the lower area to enter this one. So as this gets more and more water, it will seek this height here, and this will be the oil, and the grease and sludge will fall to the bottom. And what happens is periodically you pump this out and clean it, and then that way it doesn't allow any oil or grease to get into the system. And of course, this is a code-driven requirement for anybody who has a kitchen or anything that might induce oil or grease into the sewer system. We have sewage ejectors, and this is if you have a problem with slope. You remember that all sewer lines are gradient sloped, so they flow, and the code requires a certain slope on sewer pipes. And if building doesn't have enough elevation to get in the sewers, then you'll have to put in an ejector pump, which will pump the sewage up and into a sewer system, so you can actually then gain some height. This happens if you have buildings that have basements, 2 or 3 story basement, and much lower than the sewer line, there will be sewage ejectors that once the sewage is collected, it's pumped out of the building. Sump pumps, which are similar, but they're just not for sewage; they're just for clean water, like buildup in rain or condensate or something. And we have sump pumps. Code requires sump pumps in every elevator shaft, so the elevator shafts have sump pumps in case water enters it, it doesn't get into the elevator. Then we have sewage grinder pumps, and instead of putting a regular pump in there, you can put a grinder pump, which actually grind up the sewage in case you have a facility where people use a lot of material that flush down the toilets. And these grinder pumps are designed to chew that up so it doesn't clog the sewer lines. And then we have backwater valves. The backwater valves go on the main sewer exiting the building. And this happens to be in case the building is situated such that if a sewer clog happens downstream of your building and backs up into the manholes, it's not allowed to come into your building if your building is that low. If your building is really high, if your building is much higher than a manhole cover, you don't need them, but you would need them if your building is lower than the top of the manhole cover. And then we have septic holding tanks. So if you either live in a residence or your commercial building is such that you don't have sewer systems in the street, you'll have to build a sewer system. And to do that, we use a septic tank as a holding tank. And basically the sewage comes into the holding tank and the water fluids, and this separates the solids from the fluid. And the fluid goes out to a field, which has gravel and has trenches in the ground, and it will then seep into the earth from there. There's a lot of code requirements for how far this has to be from a well. You can't put these very close to a well because sucking sewer would contaminate the well. And you have to pump these every 10 years or so. You have to come in and pump the septic tank to empty it out. And there's some rules about what you should use in the house or in the commercial building. Have one of these because certain things, if you put it in, it will kill the bacteria in the septic tank, which is what you want. You want good bacteria in it that's digesting the sludge, and it falls to the floor. The bottom of it is solids. So there's a lot of rules around these, but this is a septic system, and this is a septic tank right here where you see the water flute comes in. Again, it's just like a grease trap, but it's not a grease trap. Whereas the solids fall to the bottom, the good water is able to flow flow into here, and then it goes on out the other side. And then, of course, you can clean both sides of the sewage of the septic tank. And then you can have private sewage systems. Private sewage systems are just small. They actually do everything a municipal sewage plant does, except they're just small. As the sewage comes in, it's separated and held and digested, and then it has agitated. These are complex. They're small but complex. One of my companies I've had in the past it actually manufactured and sold sewage treatment plants, and they were very good for small communities, especially in remote areas where they have 10 or 15 or 20 facilities, and they needed to have a sewage system. You can put in a small sewage plant. It's low maintenance, believe it or not, it's very low maintenance. You just have to kind of keep up with the chemicals that are involved in it. And then this water is normally discharged to like a pit or else a field to get rid of the water. It's not reused. It's because it's tertiary sewage water, which is got all the solids out of it, but it still has pathogens in it, so that it has to be used to can be used to irrigate. Most of the time we use it in the fields to dissipate into the earth. Plumbing drain fixtures. Okay, this is one thing. When I was a plumbing designer, this stuff will drive you crazy because there are a million different configuration plumbing fixtures. They're trimmed, the flush valves. It goes on forever, and I'll show you. I'll just show you briefly just to let you know. This is not hard. It's just complicated because there's so many options. So water closets, of course, are toilets. And this one here is a flush valve toilet. This one's a wall-hung flush valve toilet, and this is a tank toilet. And of course, the difference is this tank fills with water, and when you pull the handle, it flushes the toilet. These flush off water pressure. So these valves, you push the valve, and it will release enough water with enough pressure to flush the toilet on time without, hopefully, these are supposed to be adjusted so you don't waste a lot of water, and that's the different kinds of water closets available. And there are hundreds of different variations of what these look like, how big the bowl is, whether the seats are open in front or closed. It goes on and on and on and on. That color, of course, you get different weird colored ones. This is a urinal, and the urinals come in different shapes, and they're flush valve systems, always a flush valve system. You can get you used to be able to get a urinal with a tank up on top. They still use those in Europe quite a bit, but I don't think we use them much in the U.S. anymore. This is a bidet, and a bidet, of course, has a water faucet and a fitting to actually wash your behind, and you're done. And these are sinks, lavatories, and lavatories come in many, many different sizes, the way they look, the way they shape, their color, all that still there. We have wash sinks, and it can be porcelain, they can be plastic, they can be metal tanks. We have shower systems that are water systems. We have, all these have drains to them. We have bathtubs. We have kitchen sinks. We have garbage disposals for the kitchen sinks that grind up the food and make sure it doesn't clog the sewer lines. It makes it very small particles. Drain accessories. So this is a water closet carrier. And what this does is these wall-hung toilets just don't hook to the wall. They have behind the wall, they have a cast iron carrier and steel carrier that provide the support for this toilet, and these are actually bolted to the floor very substantially. So these carry all the way to the toilet. The pipe doesn't carry any of it. And this is a double wall carrier. And this is if you have two banks, you have bathrooms back to back, and you have two wall hungs back to back, then you use one of these. This has to be a carrier for a sink. If you have a sink like this or like this in a commercial setting, they will use a carrier like this, which is built into the wall, and these arms come out and actually carry the weight of the fixture. This is fixture trap installation. Underneath you have fixture traps, and sometimes in cold weather, these will drip, these will condensate because the sewage and the water is warmer than the air, and they will condense. So you insulate those so they don't drip on the floor. Floor drains, that's another device we have that drain the floors. This happens to be a floor sink. Call it a floor sink because it can have area drains on it. It can also have condensate pipes or discharge water pipes that go down into the sink. and provides an air barrier gap, but it also allows that sink to collect that drainage into the drain. And down here's a drain sieve as it goes into the drains. Trench drains, which are long area drains, are still put it into the drain. Clean outs, different kinds of clean outs. This is a clean out that would normally be used in a chase or something, or outside. This is one that would be used in a floor. This is one that would be used on PVC piping, and it would be exposed. And this is a cover, we call it a clean out cover, that would go on a wall to hide what's behind it. So it's just it looks like a chrome plate, which it is, but it hides and actually screws right into one of those. Or all of these come with threaded holes in them, so you can put a screw in it and put an escutcheon plate outside of the wall. And then there's escutcheons, and these of course go around pipe. This is a split escutcheon. This is one is not, so this has to go on before you finish the pipe. This one goes on afterwards, so you use those, whatever one you have to do to make it look pretty. So sanitary waste pipe, a cast iron DWV. DWV stands for drain, waste, and vent, and it meets ASTM A74 specifications. That can be compression, bell and spigot joints. So this is a compression we call no hub connections, and the pipe is just raw. And this is got a rubber band in it, and it's got two screw clamps. Put the pipe together, and you screw that together. And those normally are approved or above ground. Below ground, we normally use bell and spigot, which basically looks like this. Which you have a gasket, a rubber gasket in there, and this other piece of pipe pushes into it. PVC, again, DWV. Now remember that sewer requires very smooth transition and nothing that can catch any solid in it. So it's not different than water pipe. It has long sweeps. It has special fittings that are all drain based. So you use different fittings. So we're going to get into it in a minute. Use different fittings for sewer than you do for vents. Vents can use normal kind of fittings, but the sewage cannot. It has to use drain, waste, and vent fittings, so that's why it's different. So PVC is Schedule 40, and it can be glued or compression joints. So normally it's glued joints, but you can have it compression joints. ABS, which I'm not going to pronounce what that really is, but that's what it really is. Acrylonitrile, I don't know, whatever those are. ABS is what we've always called this, make it easy. And those are glued and compression joints. Of course, these are plastic. This is cast iron. These are a type of plastic. And you have copper. So copper can be used for drain, waste, and vents, DWV, type K, L, or M. It's kind of expensive. Big size, we don't see it much anymore. And the solder, braze, crimp, or compression joints with copper. You use brass fittings, or copper fittings, either one. HDPE, which is high-density polyethylene ASTM D3350 piping, and it can be fusion weld, glued, or compression joints. This is used for specialty chemicals, maybe. It is somewhat more corrosion resistant, especially if regular PVC won't do. Sanitary waste fittings. Okay, we got quarter bins. This is the waste, so you can see these are longer bins than normal. We have 8 bins. So if you need to go 45 degrees, you can do that. Sanitary tees. Now, I'm going to show you just the basic fittings. There's hundreds of other fittings. That was one of the bane of being a plumbing contractor. I'd go to a job site, a big job site, and you'd find a plumber out at the trailer looking through 20 or 30 big boxes of fittings, trying to find a fitting he wanted. So one of the production improvements I did is put a pre-apprentice out there to find all the fittings for him, because it gets really, there's so many of them, it's hard to see. So that's a sanitary tee. Normally this is laying down, not up. So we need a vent pipe here if it's up. And this is a sanitary tee long sweep. So you can see this got a nice long sweep for anything that's coming in here. Sanitary double tee. This is what we normally see. So you've got an entrance here, an entrance here. This is part of the stack. Clean out tee. And the reason this is a clean out tee is you put clean out up here, and you can put the auger or the jet this way, or you can put it down that way. So you can go upstream or downstream, depending on what you're trying to unclog. So that's a standard tee. We also do this a lot of time with a tee, make them up. Instead of buy one, we build one that's got a tee here and a tee here, and then they go up quite a ways at 45, and then they go out with one of these upside down to get it. So you can build these. You don't have to buy these. And, of course, couplings. eccentric reducers. On sewage, you can't use a concentric reducer, and you can only use these from going from small to big. Flow can't be this way. That can never happen in sewage. So flow has to be this way. So the smaller one emptying into a bigger pipe is permissible, but this way is not. Normally, all change in pipe size is done in the manhole, so that they can work on whatever needs to happen in case of a plug or something like that. Water closet flanges, special fitting for the bottom for a floor-mounted water closet. And then backwater valves. Again, backwater valves are designed in case the sewer line is higher. The top of the sewer manhole is higher than the house, so if there was a clog in the main sewer line, we don't want to come into the house, so they use backwater valves. This is fairly common. Many municipalities require these. They may even require grinder pumps. It depends what's going on. Sanitary vent fittings look similar, but they're not. This is an elbow, quarter bend. You can see it looks different because this is a long sweep. This is not. Vent tees, they also have 1/8. I just didn't show that. Vent tees are like a normal pipe tee. They still have a one-direction flow, though. Vent double tee, which looks like this, except it's in a short configuration instead of a long configuration. We have clean-out tees. We have couplings. And we have concentric reducers, which we can certainly use in vent piping. Normally, it ends up being in a T. Remember, these T's can always be multiple sizes. This could be full line size. This could be a size smaller. P-traps, and this is normally under sinks or whatever that require the blockage for the sewer gas. We have U-bends, which are used for some special piping considerations. Okay, so vent piping. This is the vent piping up here. It can be cast iron. It can be compressive or bell and spigot joints. It's normally compression. PVC is Schedule 40. Glued compression joints. ABS again, Schedule 40. It can be glued or compression joints. Copper DWV, sail pipe KRN. It's the same piping material as the sewer line, except the fittings are different. And of course, the copper can be brazed, solder brazed, crimp. Compression joints. Crimp is becoming quite popular nowadays for water lines, not sewers. Galvanized iron pipe, Schedule 40, you can use for vent piping. You can use galvanized iron. The original sewer system of choice was cast iron for the sewer lines, galvanized pipe for the vent lines. That's the traditional materials. However, it's not used often anymore now. Cast iron is still popular if you have a system that you want to last a long time. Now, if you want a system that's going to last a long time, you would put in a coated cast iron, which has a coating on the inside of the pipe, because cast iron will be eaten away if you have acids in your water at all. So if you do that, you put it in there, and you need a good manufactured pipe. We have seen a rash in the last 10 years or so of cast iron failure because it was foreign-made pipe, and it had a lot of porosity in it, and so the acids, mild acids, were able to eat up the pipe from the inside with a lot of leaks in a building. And if you have a high-rise building, you have to replace your cast iron pipe. It's a problem. Anyway, these are the materials for piping. Galvanized iron screw to compression joints. Special DWV piping systems. So, okay, this is called Sovent, and it is an interesting system. A lot of people don't use it much anymore, but it's a very good system for a multi-story building. Because what it does is it gets rid of this extra vent system. So the code requires that you have a full line vent, but a Sovent was designed, it has special fittings that allow so if you have water coming down here, it goes around this figure so it doesn't disrupt the incoming water. It doesn't disrupt the airflow. So this is actually a vent and the discharge line, and it will not fill up because of these Sovent fittings and the way it works. So they're available special sack. These are the special fittings you have to buy, and they're available in cast iron or plastic, PVC, HDPE, and others. So they come in different configurations. But that's the Sovent fitting. And of course, it's all done about money. And it saves a lot of money in the plumbing system if you have a high-rise building. Side sewers, 5 foot outside the building. Cast iron pipe again. Normally it's but this is actually hub and spigot. It's not no hub. PVC, Schedule 40, ABS again. HDP is used, and lined RCH, which is reinforced concrete pipe. You'll see this has this liner. This liner prevents any of the acidics or high alkaline materials affecting the concrete pipe. And of course, this is used in big sewers. You know, if you have probably bigger than 12-inch, you use concrete pipe, and anything is 24 or 36-inch, you would use reinforced concrete pipe. VCP, which is vitrified clay pipe. Now, this is a traditional sewer pipe. This VCP was actually invented thousands of years ago when they started building sewers. They found a clay material, is what they made bricks out of, and of course they made sewer pipe out of it. And it's fell on spigot. You can see it has rubber gaskets, and you plug them together. Now, originally, bell and spigot didn't have rubber gaskets because they didn't have the rubber. They actually used oakum and lead. And they would, or oakum in a sewer line, like you see, would just be oakum, which is kind of like a wood fibrous material, and they would pound like a rope, and they would pound that into the fixture, and that would make the seal, and it would stay there because it's underground. And if you were above ground or using cast iron, they would use lead and oakum. They put oakum in, and they would pour lead around it to seal the opening. So those are been around a long time. Fiberglass, VCP is fairly brittle to fracture. I mean, if you actually pound a rock into it, it'll break because it is just clay. Fiberglass pipe, side sewers, rules of materials, joints are not the same as building sewer. So it's similar. I mean, they still have to drain, they still have a slope, but they are different. They'll need they have the joints. They need to make sure they're constrained so they stay together. Especially pressure pipe, this is sewer pipes. Storm drain systems now. We have two types of drains. We have sewer drains, we have storm drains, and they don't mix normally because the municipalities don't want the storm water overloading their sewer system. So storm water drains are different and operate differently. Storm systems are storm drains for roof drains because all the roof drains have to go to a storm drain. They might be and this roof drain here happens. This is a roof drain, and this happens to be an overflow roof drain. So what happens? This is a drain that's protected for an inch or two. In other words, so leaves are the thing that normally bother. Leaves will get in here and clog this drainer up, and then what happens? This one here has a guard, so it won't let those leaves clog it until the water gets up here, and then it puts water in. So this is an overflow roof drain. This is an area drain for storm water. You got to get rid of that storm water, or you might have a manhole kind of fitting. So this is a kind of a municipal shot here. Here's the main drainage pipe sewer. This is the storm drain. So they still are in the streets, but then what they do is they take the water and discharge that water to a waterway somewhere or somewhere to get rid of the water. They do not go into the sewer system. Storm drains, holding ponds. A lot of times you go through an area, you'll see holding ponds, which is storm water is brought into these holding ponds, and it evaporates and discharges into the ground, seeps into the ground eventually. Creeks and waterways, we'll discharge the storm drains into creeks and waterways. They also have water reclaim systems where the storm drain is put into these perforated tanks underground. So the water feeds into the tanks and then slowly seeps into the earth below the systems. You have catch basin and dry well tunnels. So these are tunnels, and what they do is they put these plastic tunnels in, and then they cover them all with gravel. And then the storm water feeds into these tanks, and these tanks don't have a bottom in them. So they seep in, and what they're trying to do is they're trying to maintain, and these have perfs all through it, so that they hold the water and let it slowly drain and perk to the earth. Well, we have dry wells, and a dry well basically is used when you don't have a whole system. The water flows into this manhole, or we're going to call it the dry basin, and it has gravel at the bottom of it, and it holds it and lets it seep out over time into the adequate surface. The only problem with these is you got to make sure that people don't put anything here that's going to contaminate or seal this gravel down here. A lot of you can't put oil or grease into them because it will seal it and it will no longer perk. or you should not put any biological stuff in there that's going to rot and cause sewer gas coming up out of it. But dry wells are used for parking lots and things like that to get rid of it, or condensate pipe, if you have it coming down, you need to get rid of it. So storm drains, again, are roof drains and discharge fittings. So a lot of times a roof drain comes down and discharges onto the landscape irrigation area, and that can do. The only problem with these is if it's raining hard, you're going to have a whole bunch of water. Now, where I live, we don't get a lot of rain, but when we get it, we can get a lot of rain in a very short period of time, and floods everything. And so these are somewhat problematic if you have that kind of rainstorm. Area drains, again, you're going to have raised ones, lowered ones, 100 different ways. You can have drain filters. They put filters behind it to catch stuff. You have to clean them, but they will prevent that from getting in and clogging a drain system. Collection boxes, of course, are made prefab that have grate on top and then have ways for pipe to go release. Open channel and exit head walls, so you have an open channel with a screen on it to put water out or in your areas. This one has to be a backwater valve, so if this was in a waterway or something, you put a backwater valve on it to keep it from flooding. If the river is flooding, you don't want the water coming back up in your building. And of course, there's separate backwater valves again to prevent that from happening. And here again is oil separators. So this is the same thing with a sewer. The storm comes in, it precipitates over to the other side through this pipe, and this oil is able to be pumped out when it rises. And this is to prevent, if you have water that's collected from an area where trucks and vehicles are, you'll have to put an oil trap in before you can release it into a waterway. That's just to protect the waterway. Storm drain piping systems in buildings. Okay, cast iron, DWV again. Compression bell spigots, like roof drains, you're going to get it out of the building into the sewer drain. You can be PVC, again, DWV, glued compression joints, ABS again. Schedule 40, glued or compression joints, copper, DWV type K, L, or M. And can be solder brazier compression joints. This HDPE, high density polyethylene, DWV fusion or glue joints. So now the rules for the storm drain outside the building are totally different than inside the building. Inside the building, basically, it meets sewer pipe requirements. Outside the building, it's different. It can be cast iron again, bellows spigot pipe normally, PVC, ABS. Now, PVC and ABS are limited in size. PVC can go up to 12-inch, but I really don't recommend it. 12-inch is number one pricey. It's not that strong. ABS, same thing. If you're dealing with 4, 5, 6-inch, these are okay. If you're going to go bigger than that, you're going to go with some other material. High density polyethylene, RCP reinforced concrete pipe, and these don't need to be lined. So these is normally, if they got 12, 14-inch, 16-inch pipe, it would be concrete. PCP again, you can use vitreous clay again, or you can use fiberglass. And fiberglass is used a lot now, or different plastics. That now I got to tell you that I've given you all the traditional materials. There's a slew of plastics out there nowadays that are coming on the market, and the only trouble is you don't know how good they are, and this is infrastructure you want to last for 100 years, so you need to make sure you have good material in it. Then there's acid waste systems. Now, acid waste systems are normally coming off of some kind of process or some other kind of treatment, chemical treatment. And what that is, the municipality does not want real acidic liquids in the sewer system because it will compromise a lot of the concretes and different things that are in the buildings, like manholes that are not coated. So they want it up around a pH of around 6 or 7. They don't want a real alkaline either. They don't want a 12 alkaline because that also has a different kind of problem. So normally we use acid dilution tanks, and one of those first one is a gravel neutralization bed. Put limestone down here, which will change the pH of the material it goes through. The only problem with this is that eventually the limestone will dissolve. And so you'll have to figure out to put this in again or change it to keep the acidity where it needs to be at the discharge. Active neutralization systems, which is what normally we have now, where they take in the eye acid and put in caustic material to bring the pH up. And these have active mixers and sensors to tell you what the pH, and these you have to monitor and make sure you're injecting the right amount of chemical for the water you got coming through. And these can be big tanks or little tanks. Most of them have automated systems on them that do this automatically. They can be special control valves to limit the flow. You can't have a large amount of flow go through and wash the whole tank out and then no flow for a long time. So the flow needs to be, if you have a large varying flow, you have to put a holding tank in and release it to the acid dilution pit at a constant rate so the system can keep up with it. pH meters to tell what you're doing. Acid waste drain pipe in the lab, and whatever is normally glass, which is either IPEX or Chimex or Cronin or others. There's a lot of other different manufacturers of glass. It's fairly expensive. It has special fittings. It's compression or clamp joints, and these are normally stainless steel. So it's pretty exotic piping. Can go from 1/8 inch to 6 inch. Not bigger than 6 inch though. Polypropylene acid waste, Schedule 40, special acid waste fittings with special couplings. Fusion weld, glued or screwed compression joints. Yeah, it's 1/1/2 inch to 12 inch, so a little bigger pipe with this. And stainless steel 316 or 304L. Now glass is expensive, but stainless steel is really expensive. But if you need it, you need it. Especially glass is normally the best solution, especially if it's hot. A lot of times stuff is not good in the stainless steel. It'll take the higher temperature, but I've seen some really strange chemical reactions in the stainless steel pipe, which would say it's not supposed to corrode, but it does. It does have. It depends on what the temperature is. The hotter the temperature, the worse stainless steel does. So it can be welded flange, clamp, or compression joints. And this stainless steel is used a lot in the food industry, even though it's not acidic. But it's used for different purposes. This happens to be a clamp system, which is used in food processing manufacturing or drug processing manufacturing. And this is CIP, is cast in, cleaned in place. It's cleaned in place, so they have clamp fittings that can be opened, and they're normally cleaned with steam. Pipe 1/2 inch to 24 inch. Tube 1/8 inch to 2 inch. A lot of tubing is used for acid waste CPVC. And CPVC is Schedule 80, and it's normally a higher temperature, so it'll take a little bit higher temperature than PVC. Not real high. You can't go above 180, but still it can get up there where PVC can't do that at all. It's flange, glued, or compression joints, 1/8 inch to 12 inch. And that's basically it for sanitary piping. It didn't take very long. Kind of whipped through that. Hopefully you learned something from that, or hopefully that's something that kind of broadened your education. Anyway, I really appreciate you watching the videos. I hope you have a great day. I'll catch you on the next one. Thanks.